Imagine if every airplane carried a design flaw that engineers had known about for millions of years but could never fully eliminate. You'd call it one of the greatest failures in engineering history, yet your own body contains exactly that kind of compromise. Human childbirth has remained unusually dangerous throughout our species' existence, despite millions of years of evolution. If evolution is so effective, why didn't it simply fix it? For most mammals, giving birth is remarkably straightforward. A mare can deliver a foal and stand within an hour. Deer often give birth alone, quietly disappear into the forest, and return to grazing soon afterward. Even our closest relatives, chimpanzees, usually experience shorter, less complicated births than humans. So what went wrong with us? The answer begins nearly 7 million years ago, when our ancestors abandoned a life spent primarily moving through trees and started walking upright. Bipedalism transformed everything. Standing on two legs made long-distance travel more energy efficient and freed the hands for carrying food, making tools, and eventually caring for children. But evolution never gives gifts without asking for something in return. As our ancestors' bodies adapted for upright walking, the pelvis gradually changed shape. Instead of remaining long and wide like that of other apes, it became shorter and more bowl-shaped to support internal organs while improving balance during walking. That new design solved one problem. It created another. The birth canal became narrower and more complex. For millions of years, this wasn't a major crisis because our ancestors still gave birth to relatively small-brained infants. Then another evolutionary change accelerated. Human brains began growing rapidly. Now evolution faced two competing demands that pulled the body in opposite directions. Efficient walking favored a relatively narrow pelvis. Giving birth favored a wider one. Neither side could completely win. The result was a compromise that still shapes every human birth today. You might assume evolution would simply make women's hips much wider and solve the entire problem. At first glance, that sounds obvious, but biology rarely works that way. The pelvis isn't just part of the reproductive system. It's also the foundation of human movement. Every step you take transfers force through your hips. The pelvis supports your spine, anchors powerful muscles, and helps stabilize the body while walking and running. Dramatically widening, it could alter how efficiently those forces travel through the skeleton. Researchers continue debating exactly how much locomotion limits pelvic width. But there is broad agreement that the human pelvis balances multiple competing demands rather than maximizing a single function. Evolution doesn't pursue perfection. It settles for solutions that work well enough to allow reproduction. That's an important distinction. Natural selection doesn't ask whether childbirth is easy. It asks whether enough mothers and enough babies survive to produce another generation. If the answer remains yes, despite significant risks, the evolutionary pressure to completely redesign the pelvis becomes far weaker than many people imagine. That sounds harsh, because it is. Evolution has no goal of eliminating suffering. It has no blueprint for creating ideal bodies. It simply favors traits that, on average, leave descendants. Human childbirth exists where those competing pressures have reached an uneasy balance. Not a perfect design, a survivable one. And that uneasy balance would become even more difficult once human babies began evolving something no other animal possessed to the same extreme: a rapidly expanding brain. Human babies arrive astonishingly underdeveloped compared with many other mammals. A newborn foal can stand within hours. A baby gazelle may be running the same day to escape predators. A human infant can't even hold up its own head. For centuries, this seemed like evidence that our babies were simply born too early. Modern evolutionary biology tells a more complicated story. Human brains grow at an extraordinary rate before birth. By the final weeks of pregnancy, the fetal head is already approaching the maximum size that can usually pass through the mother's birth canal. If pregnancy continued much longer while maintaining the same rapid growth, many births would become even more difficult. At birth, the human brain is only about a quarter of its adult size, yet it is still enormous relative to the mother's pelvic opening. This creates one of evolution's greatest balancing acts. Babies are born neurologically immature, but with heads that are already exceptionally large. After birth, the brain continues its explosive growth outside the womb, supported by constant parental care. That extended childhood is expensive. Parents invest years of food, protection, and teaching into every child. But it also allows something remarkable: a brain capable of learning language, culture, technology, and social behavior at levels unmatched by any other species. The very intelligence that defines humanity begins by making birth dramatically more challenging. Then comes one of the strangest features of human childbirth. Human babies don't travel through the birth canal in a straight line. They rotate. As labor progresses, the baby's head typically enters the pelvic inlet facing sideways because that is often where the available space is greatest. As it descends, it performs a series of rotations to navigate the changing shape of the birth canal before finally emerging. This process is known as the mechanism of labor. It is remarkably complex. The human pelvis isn't a simple tube. Its dimensions change from top to bottom, meaning the widest direction at one level is not necessarily the widest direction farther down. The baby must continually adjust its position while powerful uterine contractions push it forward. Even slight differences in fetal position can influence how smoothly labor progresses. Our closest ape relatives usually don't require such elaborate rotations because their pelvic anatomy differs significantly from ours. In humans, however, these movements became part of the solution, not because they are ideal, because they work often enough. When everything proceeds normally, the baby completes this extraordinary journey successfully. When the rotations don't occur as expected, labor can become prolonged or obstructed, explaining why childbirth has always carried risks long before modern medicine existed. The process appears almost unbelievably complicated, because it is. And yet millions of successful births every year demonstrate just how finely balanced this evolutionary compromise has become. The next mystery is even more surprising. Why are humans one of the few species that so often benefit from help during childbirth at all? For most mammals, giving birth is a solitary event. A pregnant female finds a quiet place, delivers her young, cleans the newborn, and rejoins the group when the danger has passed. Humans are different. Across cultures and throughout recorded history, women have often been assisted during childbirth by relatives, experienced mothers, or skilled birth attendants. Anthropologists call this widespread pattern obligate midwifery, reflecting the idea that human childbirth frequently benefits from assistance in ways uncommon among other primates. Part of the reason is purely anatomical. Because the baby usually rotates while moving through the birth canal, it often emerges facing away from the mother. That position makes it more difficult for her to immediately guide the infant, clear the airway if needed, or untangle the umbilical cord should complications arise. An extra pair of hands can make an enormous difference. But anatomy is only part of the story. Human infants require immediate warmth, feeding, and protection. Mothers recovering from exhausting labor may have limited strength during those first critical minutes. Assistance improves the chances that both mother and baby remain safe. This wasn't simply kindness. It became part of humanity's survival strategy. Long before hospitals existed, cooperation increased the odds that another generation would live. Once again, evolution didn't eliminate the problem. It helped create behaviors that reduced its consequences. Here's where the story becomes even more fascinating. Evolution doesn't act only on mothers. It also shapes babies. Not every newborn has exactly the same skull. Unlike the solid skull of an adult, a baby's skull consists of several separate bones connected by flexible fibrous joints called sutures. The soft areas where these bones meet are known as fontanelles. This isn't a flaw, it's an adaptation. During labor, the bones can overlap slightly in a process called molding. That temporary change in shape allows the head to pass more easily through the birth canal. After birth, the skull gradually returns toward its normal form as the bones continue growing and eventually fuse over time. Without this flexibility, many more births would become impossible. The same design serves another purpose. Because the skull isn't completely fused, the rapidly growing brain has room to expand throughout infancy and early childhood. One adaptation solves two problems at once. It helps the baby be born, then it supports the fastest period of brain growth in the entire human lifespan. Even so, there are limits. The skull can only mold so much, and the pelvis can only accommodate so much. When those limits are exceeded, obstructed labor can occur, a condition that has threatened mothers and babies throughout human history and remains a serious medical challenge in parts of the world today. Evolution didn't create unlimited flexibility. It created just enough to keep the balance from collapsing completely. And that delicate balance has defined our species for millions of years. For centuries, scientists assumed they had already solved the mystery. Wide hips help childbirth. Narrow hips help walking. End of story. But recent research suggests reality is even more complicated. Human pregnancy itself may place limits on how large a baby can grow before birth. Throughout pregnancy, the fetus depends entirely on nutrients and oxygen supplied by the mother. As the baby grows, its energy demands increase dramatically. Eventually, those demands approach the mother's metabolic capacity to support both herself and the developing fetus. Some researchers have proposed that this energetic limit helps determine when labor begins, an idea known as the energetics of gestation and growth hypothesis. Others argue that pelvic anatomy remains the dominant factor, while many scientists believe both influences interact rather than competing as separate explanations. The debate continues. What doesn't change is the evidence. Human childbirth reflects multiple evolutionary pressures acting simultaneously, instead of a single design constraint. That's exactly what evolution usually produces. Not perfect answers, complex compromises. When several biological systems compete with one another, no solution satisfies every requirement equally well. The human body carries the fingerprints of those compromises everywhere. Mothers survived because their bodies, their communities, and often experienced birth attendants carried them through one of life's most dangerous events. Today, obstetrics has changed that landscape. Procedures such as cesarean delivery save millions of lives every year when labor becomes obstructed, or complications threaten the mother or baby. Conditions that would almost certainly have been fatal thousands of years ago can now often be treated successfully. Some people wonder whether this means evolution has stopped acting on childbirth. The answer is no. Evolution never truly stops. It simply responds to changing environments. Modern healthcare alters which individuals survive and reproduce, creating conditions very different from those faced by our ancestors. At the same time, cultural practices, nutrition, sanitation, and medical technology now influence birth outcomes alongside biology in ways that natural selection alone never could. For the first time in human history, technology has become part of the reproductive environment. Our bodies still reflect millions of years of evolution, but our survival increasingly depends on knowledge rather than anatomy alone. That may be the most human adaptation of all. Instead of waiting for biology to solve every problem, we learn to solve many of them ourselves. If evolution has had millions of years to improve childbirth, why hasn't natural selection simply favored women with much wider birth canals and babies with much smaller heads? Because evolution rarely optimizes one trait in isolation. Every characteristic in your body interacts with dozens of others. A larger birth canal might reduce some delivery complications, but pelvic anatomy also influences how muscles attach, how the body supports internal organs, and how forces are distributed during movement. Likewise, a much smaller newborn brain could make birth easier, but it might also reduce the developmental advantages that have helped humans become one of the most cognitively capable species on Earth. Natural selection weighs the overall outcome, not individual comfort. If a particular combination of traits allows enough individuals to survive and reproduce successfully, it can persist for hundreds of thousands of years even if it carries serious risks. That's why human anatomy often appears imperfect, because perfection was never the target. Reproductive success was. There's another misconception that refuses to disappear. Many people imagine childbirth has always been equally dangerous everywhere throughout history. The archaeological and historical evidence paints a far more complicated picture. Risk varied enormously depending on nutrition, disease, maternal health, age, social support, and access to experienced caregivers. Chronic malnutrition could reduce pelvic growth during childhood, increasing the likelihood of obstructed labor later in life. Repeated infections weakened mothers long before labor even began. On the other hand, healthier populations with reliable food supplies often experienced better birth outcomes than communities facing constant famine or disease. Environment mattered. Culture mattered. Knowledge mattered. Even simple practices, keeping the mother warm, providing clean water when available, recognizing when labor was progressing abnormally, and offering skilled assistance, could improve the chances of survival. Childbirth was never shaped by anatomy alone. It reflected the entire world surrounding the mother. That's one reason no single explanation can fully account for human birth. Biology sets the stage. Everything else influences how the story unfolds. And despite all these risks, generation after generation continued bringing children into the world, allowing humanity to spread across every continent except Antarctica. The greatest evolutionary success of our species emerged from one of its greatest biological challenges. That paradox has defined human history from the very beginning, and it leads to one final question that completely changes how we should think about evolution itself. So why didn't evolution solve childbirth? Because evolution isn't an engineer trying to build the perfect machine. It doesn't sit down with a blueprint, identify flaws, and redesign the human body from scratch. Every new adaptation has to work with structures that already exist. It can only make small changes over many generations, and every change creates new trade-offs somewhere else. Human childbirth sits at the intersection of several competing evolutionary pressures. a pelvis built for efficient upright walking, a baby with an unusually large and rapidly developing brain, a pregnancy limited by both anatomy and maternal physiology, an infant that must continue growing for years after birth. Each feature provides enormous advantages. Together, they produce one of the most challenging births in the animal kingdom. The remarkable thing isn't that childbirth is difficult, it's that it succeeds as often as it does. Millions of healthy mothers and babies throughout history are evidence that this delicate compromise has worked well enough for our species to survive, spread across the globe, and eventually build civilizations. Painful doesn't mean evolution failed. Dangerous doesn't mean the design is broken. It means every advantage came with a cost. When people ask why evolution didn't fix childbirth, they're really asking the wrong question. The better question is this: why would evolution eliminate a problem that still allowed humans to become the planet's dominant species? Natural selection never promised comfort. It never promised safety. It never promised perfection. It only favored combinations of traits that produced surviving offspring more often than the alternatives. That is why your body still carries the marks of millions of years of compromise. Your spine aches because it evolved from four-legged ancestors. Your eyes contain blind spots because evolution modified existing structures instead of starting over. And childbirth remains extraordinarily difficult because the same species that evolved to walk upright also evolved the largest brain relative to body size among living primates. Those two achievements collided inside the human pelvis. Everything that followed was a negotiation rather than a solution. In the end, evolution didn't fail to solve childbirth. It solved a far bigger problem. It produced a species capable of language, science, art, engineering, medicine, and curiosity powerful enough to ask why our own bodies work the way they do. The price was a birth unlike almost anything else in nature, a compromise written into every generation of human history. And perhaps that's evolution's most important lesson. Nature doesn't create perfect designs. It creates survivors. Sometimes surviving is the only definition of success evolution has ever needed.